Hi there, everyone. Good evening and welcome to the November 2020 edition of PHP Leads. I hope you're all well, and we've got a couple of great talks lined up for you this evening. So the first talk is going to be by Irene, and it's basically on the subject of how are we teaching machines to learn. Then we'll be followed by a short break at 7:20, and then after that we're going to have turbocharged development with Docker, PHP Storm, and Xdebug by James. After James's talk, please feel free to join us in the social area afterwards for a chat and grab yourselves a beer. Please take a minute to look at our sponsors, who, without them, basically, we would not be able to do this event. So we have BGSS, Searchability, and Bruntwood. If you'd like to join us on Slack, there's the URL there. It's kind of quiet at the moment, but hopefully we can build a good community. Upcoming news is, unfortunately, there's no meetup in December because basically we're just getting ready for Christmas. So this is the last one for 2020. So I hope you have a great Christmas. And now I'm going to switch over to the first talk, which is Irene. Hello, Irene. So Irene's a computer science student at the University of York, and she's currently exploring different areas of technology, from web development at Legend to software engineering at NatWest, and AI and computer vision research at the University of York, which all sounds exciting. So she's now going to talk to us about how we were teaching machines to learn. Over to you, Irene.
Hello, everyone. My name is Irene, and as Mark introduced me, I'm going to talk to you about how we're teaching machine to learn. So today we'll go through the definition of artificial intelligence and machine learning. We'll look at some machine learning algorithms, applications of this field, and then we're going to go through a quick examples. I'm going to leave you with resources that you can use to explore this field further. So what is AI? AI is a computer that performs tasks that are usually associated with humans. These might be going to pick up your kids from school, making popcorn, hugging someone when they're sad. This is what we define as AI. In reality, there are two definitions of AI. AI can be strong or weak. Strong AI is everything I just told you. It's basically a human. You could represent it as being a human. A weak AI instead is something that basically does one thing. It does it really, really well, but it does one thing. And these might be, for example, Siri, Alexa, a chatbot. They do one thing, but they do it really well. Although, I mean, I've had some problem with Alexas, but that's another thing. But they usually do it really well. Machine learning, on the other hand, is an algorithm that is a set of algorithms that improve through experience. So basically, they're not really the same thing. People often associate them as being the same thing, but they're not. And recently, we've seen that there's been this hype around the world, ML and AI. So as you can see, there is a trend since 2004 that has been steadily increasing, and in the last few years, it's been increasing a lot. There's a really recent dip, but yeah, that's just as the other dips are here. And this is not because we just discovered AI or machine learning. It's really got nothing to do with that, actually. It's because of data and computational power. So recently, right now, we have a lot of data, and the computational power of our computer is a lot higher than it used to be when we initially started researching into this field. So of course, back then, you would need days and days and months, even longer, I guess, to compute the outcome of an algorithm. Right now, we can do that a lot faster, and the data that we have to train the algorithm on is a lot more. So as you can see, yeah, this is the reason why AI and machine learning is such a big hype now. Another reason is because we have a lot of data and a lot of performance in comparison to what we had before, we can actually do deep learning. Deep learning is basically classified as a set of algorithms which imitate the human brain. So they perform as the human brain. We don't really have a lot of time to talk about deep learning today because this talk is just an introductory talk to machine learning. But if you're interested, I suggest you go and look at it because it's really, really interesting. So as you can see, for the same amount of data, deep learning performs really, really, really better than machine learning, even the most advanced ones. And this is why we now have this hype, because deep learning has been introduced and the performance is so much higher. So yeah, now we're just going to talk about different types of machine learning algorithms. We classify machine learning algorithms based on unsupervised and supervised algorithms. What do we mean by supervised? Supervised is basically when you provide the algorithm with data that is labeled. So you have some X and you also have the Y to train the algorithm on. And these will make sense now that I talk about one specific type of supervised algorithm, which is classification. So for classification, basically imagine that you have a box of fruit. And in this box of fruit, there is apples and pears. So you've got this box of fruit and you train the algorithm saying for every item that you pick out of the box, you say, this is an apple, this is a pear, and you do it for every item in the box. Okay, so now your algorithm has all the information it needs. It knows that you have a set of data and it knows what class this set of data is on. So then you show the algorithm a new fruit, which is an apple or a pear, but you don't tell it what fruit it is. So the algorithm is going to predict whether the fruit is an apple or a pear based on what data you showed it in the past. So this sounds really trivial and really easy. It's just apples and pears. But this is actually the mechanism for email filtering. So for email filtering, we've shown algorithms what email is spam for a large set, and then what email is a normal, just a normal email that you would receive from your friend or anyone. So based on the features that are contained in emails that are normal and in emails that are spam, the algorithm is now able to classify whether the email that you just received is spam or not. And that's why you mostly, I would assume by now, have an inbox which is actually just normal emails and no spam. On the other hand, we have a regression. A regression is still a supervised algorithms, and it basically aims to find a mathematical function between the data you provide and the output that you provide it with. So you train your data and you give it an output. So you just ask the algorithm, all right, you have a lot of data, please find a function that relates this data to the output that I provided you with. This might be something like the number of hours you spend studying, what grades you've got in the past tests, and your final exam grade, or anything else healthcare related. So this is really useful because after, when we present the algorithm with a data which is new that it hasn't seen before, it is able to understand where the new data would fit in the function, and then just give you the value that the function returns. So yeah, this is supervised. And as I hope now you can understand, it's because we're basically holding the algorithm's hand while it learns. So we're teaching it effectively what to do and why you get a certain response at certain times. On the other hand, we have unsupervised. Unsupervised learning is when, going back to the fruit analogy, we have a box of fruit, and you've got apples, pears, oranges, I don't know, and yeah, bananas. So you've got this box, and basically that's it. You have the box, you give the box to the algorithm, you say, all right, good, whatever, divide them into groups. And you're not really supporting the algorithm in this process. You're just saying, all right, learn by yourself. And as we would do it, the algorithm goes and tries to find features that are similar in between different elements in the group. So you might notice taste or shape, color, the surface of the skin, anything like that. So based on these features, the algorithm then forms these groups, which are called clusters. And it basically forms the groups of what where the features are all the same. So we end up with these groups for our fruit. And then that's it pretty much. The algorithm has learned the clustering, the clusters of the group. However, it will never tell you that one is an apple or another one is a banana, because you didn't tell it what it was a banana and what was an apple. It just knows that the items belong in the same group. So when we present it with an easy peeler, for example, you can see where the problem is, because it's not an orange, but it's definitely not an apple or a banana. So the easy peeler kind of ends up here, as we can say that's the data for the easy peeler image. And then the way the algorithm works on prediction is that we have this data here, and we see that it's a certain distance between the features on this group, and then a lot longer distance from these groups. So the algorithm understands that the distance is closer based on the features, and it basically clusters it in that cluster, because it's closer to being an orange than being a banana or an apple or a pear. So yeah, this is the main difference between supervised and unsupervised. On one hand, you're helping the algorithm learn. On the other, you're just throwing it off in deep end. It just will learn and hopefully won't mess up when you learn. So this field has a lot of application. I will not list every application that it has, because there are so many applications, and it's really interesting to see where it will take us in the future as well. So for example, we have facial recognition. A lot of phones now, you just pick them up and they allow you to enter if you're the owner of the phone. It doesn't even need, you don't need to enter a password or anything. It just knows it's you, because it scans your face and compares it to the face that was stored in the database. We have self-driving cars, and these are powered by machine learning algorithms. And here it's really interesting to see where the line between computer science and ethics really is drawn. Because if you start thinking about it, then what if something happens? Is it the driver's fault? But it's not really, because the driver was in a self-driving car. So is it the algorithm's fault? Although the algorithm only learned because of data you provided it. So is it the programmer's fault that programmed it wrongly, or the data provider's fault? So as you see, we just start going through these rabbit hole, I would say, of whose fault is it? And it's really interesting to see the ethical implication that AI might have in this field. Then something which really doesn't have that much of a ethical implication, I guess, is Netflix. So Netflix just suggests you what movie you might want to watch later based on what movies you watched or what you rated as good or bad. Starbucks, as I'm not really sure whether this is a prototype or it's actually in commerce right now, but basically there is an app and you can order your usual Starbucks coffee based just talking to a chat box, which is really cool. It basically employs the science of NLP, which is natural language processing, to understand what you're asking it and how it has to reply and what it has to sell you. So for example, if you want an extra shot or anything like that. And then we have Google. Google basically uses ML to improve the searches. So when you're typing, you don't always finish typing, and you see some suggestions already being brought up. That's because of your search history, and also because of what people have been searching at this time, around like this time. So for example, if you search something about coronavirus now, it's going to be filled with all information that you might need and a lot of search histories, because it's a really hot topic now. There are so many other fields that an application of these, healthcare, finance, it's really everywhere. So this is not an exhaustive list, but I didn't want to take up too much time with this. So yeah, this is a really messy graph, but it's just to illustrate that the process of machine learning is not always straight and like, easy to understand. It's just like a bit of a mess sometimes. So the main 3 points here are data, learning, and prediction. So these are the most 3 important points in machine learning. You've got data, and you need to make sure that this data is of high quality and high quantity. So the data you are looking at must be descriptive of the sample. So for example, going back to the student, you shouldn't only have students that always get 100 and spend 10 hours studying, because that's not really representative. That's just a lot of data, but based around that single mathematical point, which means that if you show the algorithm something that it has never seen before, really far away from that, it's not going to be an accurate prediction. You also need to record the data, which is a really important point, because recording data might be really costly. So that's a really important point. We then can divide the data into training and testing sets. So you leave some data out for training the algorithm, and then a remaining proportion to test the algorithm and see if the model actually does what you want it to do, and if the accuracy is high enough for you to use that model. We then adjust these parameters and test it a bit more to understand the actual parameters that we want to use. And then when the model is ready, we run predictions based on that model which is just trained. So yeah, now I'm just gonna do a very quick code demo. I am running these on the same example that we've been talking about pretty much for all the talk. So we have a student, and this student spent 5 hours studying and got a 50 on his midterm grade, and we want to know whether he passed the exam or not, will pass the exam or not. So what we do is collect the data from last year's student distribution, and we see this data. So we can see that if you only spend 1 hour studying and your midterm grade is 7%, then you're gonna fail. And on the other hand, if you spend 6 hours studying, but you get 90% on your midterm grade, you're gonna pass, which is pretty intuitive. So if you study more and you get a higher test grade, then you're gonna pass the exam. So yeah, we're going to run these on PHP. Okay, so this is our code. I just imported some libraries. We are using PHP machine learning as a library for this code. And as you can see, we have the samples. This is just the X values. So this is the data that we observed. So 110, this is the number of hours, and this is the number of the midterm grade. And then we have the labels, so the Ys, the fail, pass, and all of these, which tell us that for this student with these X values, they failed. We then start an instance of this SVC, and we use the classifier to train it. So we start the machine learning model, and then we decide to train it based on the X and the Y. So the samples, the samples and the labels. We now see that after this, it's pretty much done. I'm not showing you the division between training and testing set because we don't have enough time to go into it, but you could probably do 75% training and 25% test. But as you can see here, we only have, I think, 7 data points, which is really not enough. It's not a representative proportion of the data. So even doing a division between testing and training data it would hurt the training system because there's not enough data to do this division. So we just train on all the data, and we don't do any testing in this case. So we train all the data on samples and base and labels, and we ask the algorithm to predict for that student, if the student studied 5 hours and got 50% on the midterm, what they would get, and the second one, this should be 100. So we run this, and as you can see, the algorithm decided that they both pass, which kind of makes sense, because if we remember from our previous slide, then the algorithm said that if you basically pass this threshold and you got 5 hours and you've got at least 50%, then most of them in the table passed. But what if we say that we spend 7 hours studying, but we only get 10%? So now it starts getting a bit trickier, because on one hand, we have a variable saying that we should pass because we spent a lot of time studying, but also we didn't really get a high grade. So we need to look at the correlation that each of these has to this y. So we run it again, and we see that we pass it for the first one, as you would say, because we didn't really change anything, but we fail for the second one. And this is because we changed this value based on that. So we can see how these kind of work. So yeah. So now we could fill this in and say pass and pass, and then use this data, the actual data that the student will get this year, for the prediction of next year. And every time you accumulate more data, this just keeps getting better and better. So yeah, I thought I'll leave you with some resources to get started in machine learning. As I said, it's an incredibly vast field. So if you're interested, there's a lot of tutorials and interesting theoretical side of things on Medium, which is just a platform where you can read articles written by developers and other people. But yeah, if more related to PHP, there is this PHP ML library, which is what I've used to do the demo today. And there's also Rubik, which is another PHP machine learning library, which is down here. I've also found this tutorial, which looks really cool. You basically give it a tweet or Twitter feed, and it will tell you what emotion the person writing the feed is, or the tweet is feeling, which sounds really, really cool, in my opinion. So yeah, this is pretty much the end. So yeah, just a cute, tiny GIF. I don't know, it's not playing. Never mind, it's not playing. But yeah, oh, it is playing. Yeah, so you can find me on Twitter at that handle, on LinkedIn, GitHub. Yeah, you can find me pretty much anywhere. But yeah, if you've got any questions, thank you for listening.
That was a really interesting talk. Thanks for that, Irene. It's certainly an interesting subject, and to be honest, if I was to start out my career now, I'd probably go for data science because it's so interesting.
It's super cool. There's so much data now that you can analyze and run tiny projects on, even for yourself. So it's really fun.
Yeah, indeed. I hope we can get you back sometime to do a longer talk on that. It would be good to hear more about it.
Would be great.
You're always welcome. So I think since we're basically the time is aligned, so I think we should basically move on to the next talk if that's okay with everyone. So hi Jim, how are you doing?
Hello, can you hear me?
I can indeed.
Hello, how are you doing?
I'm good.
Thanks for hosting me. I love a bit of machine learning type stuff. My wife is a data scientist, and I know nothing compared to her, honestly.
I think basically the more that I learn, the more that I realize I know nothing. So
That generally tends to be the way, yeah.
So just a little introduction. Jim's a developer advocate at Jump24. He's the founder of Birmingham PHP and host of Fusion. is also a speaker and a DevRel strategist. And to be perfectly honest, I'm not sure what DevRel is, so maybe you can let me know. So Jim's going to be doing a talk on turbocharged development with Docker, PHP Storm, and Xdebug. So over to you, Jim.
Let's see if I can get my screen sharing right. Go on, Chrome. Don't be terrible. There we go. That looks nice. Hello, everyone. DevRel is developer relations, which is a relatively new field where it's the evolution of developer evangelists that used to be marketing people that would go and speak to people. As the world of tech has all advanced these days, lots of people are creating APIs as products and things like that, and therefore all of their consumers are all developers. So it's all of your strategy of how you connect one-to-one with developers, which incorporates lots of talks and education and writing blog posts and networking on the ground and things like that. So there's my whistle-stop tour. Hello, everyone. Thanks for the intro. There's a little bit of this on the slides anyway, so I'll just quickly go through. Talking of time, I'm going to absolutely motor through this in order to be able to sort of roughly be on time, because this is a live code demo and it tends to be a bit. Tends to. I try to not make too many mistakes because it will drag. But anyway, here's a little bit about me. So as mentioned, I founded Birmingham PHP, which was the new evolution from PHP West Midlands. I co-run Fusion Meetup with the team, the Fusion team, which is a quarterly conference stroke meetup kind of crossover. And most importantly, I do developer relations for Jump24, which is a Laravel partnered studio in Birmingham. Some websites there for you. Jump24's website there. Have a look at our engineering blog. You'll find some really cool stuff. You'll find the accompanying article to this talk. There's devtheatre.net, which is my personal website, which you can go and check out if you want to check out my radio show where I play lots and lots of really strange records that I like. If you want to go onto the Horrible Bird website and send abuse, there we are at Conj, and you can use the new... What is it they called it? Fleets. You can use fleets. You can fleet me. Absolute rubbish. If you are a fat, balding white man in his 50s, then you can connect to me on LinkedIn and try and spam me there. If you want to see a horrible graveyard of terrible projects that are unreleased, personal projects, then you can go onto GitHub and look at my terrible Octocat collection. So that's me. So debugging, where to start? Debugging is a pretty dry subject, so I had to sort of think of some sort of thing to try and tie it into something that so it's not completely flat. I didn't think it could be done, and it turns out it can be done. And I call it sports casual debugging, which is named after the inventor and master of sports casual, Mr. Alan Partridge. There he is with his Millennium Pink salmon shirt, just casually sort of throwing something over it, throwing his jacket over his shoulder. And it goes a bit something like this. So here's some debugging. Here's some classic debugging stuff that as PHP developers, we've probably seen and used, right? So var dump, dd, dump, and xdebug. Sports casual debugging looks like this. You can compare it to cars, because everything can be compared to cars. Just for everyone's a bit of information, I'm actually learning to drive and I don't drive. And I'm also not interested in cars whatsoever. So var dump, that is a Ford Mondeo. It appeared in the mid-90s. It is littered absolutely everywhere. It seems to be reinvented and isn't going anywhere. But I mean, it does what it says on the tin, but it's the definition of vanilla pretty much. DD and dump, if you've seen either of those. And I have gone for the BMW Mini. So it's an old design underneath the hood, but has been taken over by industry leaders and ramped up, turbocharged, if you will. And Xdebug is the Audi TT Coupe. Is that what Coupe is like? I don't know. It's a hard top. I don't know if that's what that thing is. But it's sporty and it's sleek and it looks sort of super cool and turbocharged. But the important thing is it's surprisingly more affordable than you'd think, because that's the reason why I didn't put a Lamborghini, or as my dad would say, Lamborghini. He never kind of worked out how to pronounce it properly. So that is it for the comedy. Let's get on to why at Jump24 this talk came about and why I wrote an article and then it turned into a talk. So at Jump24, we're all about shipping code quality code with a large selection of tooling as part of our process, where pipelines are built into all of the code that we ship, and everything runs on every commit, or it runs on every deploy, things like this. So some common things that you can see there: composer scripts and things like that. PHP code sniffer, the squiggly line gives me anxiety just looking at it. PHP units, we do TDD because everybody does TDD these days. Everyone. And if you're not, why? Go and speak to Kieran McNulty and he'll tell you that you have to do it. And GrumPHP runs on everything. I currently would... Previously, I would have said how much I love GrumPHP, but I am fighting it regularly because it's very picky. So as part of our process for how we develop software at Jump24, for all of our local environments, we use Docker. We have Atlassian Cloud for, Jira and Bitbucket. We adhere to GrumPHP and PHP code sniffer and things like that are all set to our PSR standards. So we adhere to the coding standards of PSR 12 and its expanded PSR 12. And as mentioned, Composer, GrumPHP runs all the time. We do everything TDD. And everything's built into CI. So we have either Jenkins boxes for everything that runs on the project that we're about to see. We actually have Circle CI for it, which then runs all these things so that you can't actually deploy. So bearing in mind with all of this, the question we wanted to ask, and I'll get onto in a sec why we asked the question, is can Xdebug be part of this process? Because it's not currently, and we use DD, and we use var dump, or we use dump for everything. Should Xdebug be part of the actual process where it's part of our Docker stack? And when we deploy, when we deploy, you obviously can't do it because it's live, but if you had a UAT environment, could you access it on there? So onto why Xdebug. This talk and its accompanying article is all the fault of Derek. There he is. And he put out a tweet this year and said, if you don't use Xdebug, then you're an amateur. And social media went absolutely bonkers. And everyone said, I'm an amateur, I'm an amateur, I'm an amateur. But technically, at Jump24, we were amateurs because we didn't use Xdebug. And we sort of thought, we had discussions on it. Like Xdebug is nothing new, right? It's been out, it's been around since 2002. So some thoughts on Xdebug. So it's been around years, and probably the most obvious thing that PHP developers say all the time is it's complicated to set up. It was complicated then, and bearing in mind that we've got things like Docker, and if we're suicidal, we've got Kubernetes. How are you going to introduce Xdebug into all of these virtualized machine environments and things like that? Isn't that just going to make it more complicated? And as I mentioned previously, why don't you just use die-dump? Why don't you just cancel, kill the request and dump out everything? Why can't that happen? So, with bearing that in mind, we need to be open in our sort of research and development of how we approach things, right? So we thought we needed to give it a test drive. So the test drive you'll see on the live code demo is this project. It's a real project to make things more interesting. It's called Order. There's the GitHub link for it, and Order is a system for it's an open source piece of software for merchants to take payments and then arrange deliveries for takeaways, fast food, anything like that. And it was built in 6 weeks in response to COVID. And we are actually we've still got people sort of using it. COVID's obviously not going away. And its stack looks like this. We're Laravel partner studio, so it's in Laravel. It uses Vue.js, just rolling that out for table ordering, live table ordering stuff. It's hosted on GitHub. It's hooked into Circle CI. And if you want to develop locally, there's a whole Docker setup for it. So bearing that in mind, let's set it up. So here is PHP Storm. And to start off with, we need to get, this is actually, if I just show you this Firefox, this is the front page for Order, right? This doesn't have Xdebug set up on it. So I'm going to do it. So here's how you do it. First of all, we need to get, we need to install it in our, we need to install Xdebug in our Docker file. So if I bring up the Docker file for PHP in our project, actually, I'm just going to show you Docker Compose first, so you just show you roughly what the stack looks like. So we've got an Nginx container, PHP, MySQL is the database, got Redis for caching sessions and things like that. I'll get onto WebGrind and show you what that does later. It's a fairly sort of LAMP stacky kind of thing. We have a Docker file for PHP. There it is, 7.4 FPM. So installing Xdebug is as easy you'll find out why that's a lie. Pickle install Xdebug in the Docker file. You have to use Pickle to install Xdebug when you're compiling it in a Docker file like this, but that is it. Simply do this. But of course, it's never, ever say simply in anything. So that will install Xdebug into your container, but Xdebug needs to be configured. So in order to get it configured, you have to insert a custom PHP INI set of parameters. So in order to do that, I'm going to go to this folder and create a new file, and I'm going to call it xdebug.ini. And the setup stuff looks like this. I'll just tell you what, talk you through those things. The Zend extension is called Xdebug, standard Zend thing for the Zend engine. Remote enable and auto start are really, really key. Back in the day, when you used Xdebug originally, you had to do things like bookmarklets in your browser, which would stop runtime and send a thing to the server, to the Xdebug server, which would then pause runtime. That was all very, very fiddly. This, if you hit it, it has a remote enable. So anything that's listening will just automatically shift the focus to it. The remote port is set to 9000 by default, but I think for Xdebug 3, Derek has actually changed that. So make sure you change it. I put it to 9001 because otherwise it conflicts with PHP FPM. And the remote host this is a key thing for this is on a Mac, but you have equivalents on Windows and Linux. There is a host.docker.internal reserved keyword that is your entry point via an IP address that's reserved into the stack. And that solves all of the nightmare headaches of having to do things like Xdebug remote IP export in like Bash and stuff like that, which was horrendous. So with those in mind, that needs to be injected into those INI settings there need to be injected into the Docker container. So you can do it in the Docker file if you want, but I'm going to do it in Docker Compose. So if I go back to the Docker Compose file, go to volumes, and I have a line pre-prepared here. In the mounted volumes, I've now said go to Docker PHP Xdebug.ini, which if I scroll around here, there it is, Xdebug.ini in the PHP folder. And I want you to copy that to the the system files, local etc php conf.d /xdebug.ini. That path that is in the Docker container is the path to all of the INI files that are picked up by PHP on compile. So you inject this externally into there, and then it should get picked up. Last bits of setting up PHP Storm. So here is something that's a real gotcha. You don't have to do this if you're going to do it with VS Code, but this is a talk with PHP Storm in mind. So you have to give the PHP container a custom environment variable, and it looks like this. That is PHP IDE config, and the string you give it needs to look like that. And it's server name equals, and then the local DNS that you're going to be using to serve it on. So in this case, it's ukrestaurants.test is what is in my hosts file of what I'm serving it on. And the reason why you need to inject it like that is because when you have incoming, you tell PHP Storm to listen to incoming connections. It does not know whether it belongs to the project or not. It could just be anything that's firing on port 9001. So bearing that in mind, you have to set up on PHP Storm, you have to set your project up in with the web servers thing in PHP Storm, which personally I absolutely hate and haven't done before. But for this, in order to be able to map correctly for the incoming request, you need to do it. And it looks like this. First of all, you need to tell PHP Storm to listen to the right port. So if I type in Xdebug into here, there we go. Xdebug is there. There's a switch there. It says, what port are you listening to? So make sure you put it onto 9001. And the second part is servers. Not severs. Servers. Languages and frameworks, PHP servers. There we go. So this is the setup. I've got an arbitrary name at the top, which is ukrestaurants.test, but importantly, it matches the host here. So the host is ukrestaurants.test. The port is 443 because nobody is using HTTP anymore to host stuff. And the important bit out of all of this is project mapping for your directories. So if you leave it alone and you switch on the listener, when you get an incoming request, it will automatically think that it's come from the public folder, which is the same for Symfony and it's the same for Laravel. And that is not what you want, because that's not the actual root of the folder. The root of the actual directory root is, you can see it on here. You've got project folders and it's users, gym, sites, order, core. That is the Laravel root, like the root directory. And it maps on the right-hand side in the Docker container to var www/vhost, which is an Nginx thing. If you don't do that, it will get completely confused and it won't map properly. So with all of that in mind, I need to rebuild Docker and see if we're all looking good. So if I go to my command line, is that right? Yes, yeah, it is. Okay, cool. So Docker's running at the moment. So Docker compose down. Kill all the things. And because I've put all of the PHP, the Xdebug stuff into the PHP container in Docker, everything when rebuilding should now work hunky-dory. So Docker compose up, run it as a daemon, and build. It goes, and it's rebuilt. So in order to check whether we've actually got Xdebug installed or not, I can SSH into the box. So Docker executes UKR PHP, I think the name of the container is. Bash. Yes. And if I do PHP version, there we go. Zend engine version 3.4 with Xdebug. So it's made it on there. The next thing to do is, now that we've got Docker on, I want to make sure that the web portion and that INI file that we injected has been injected properly. So I'm going to stop runtime for the first time. If I go to my IDE and I go to app.php, this is the bootstrap for Laravel. And if I do a die dump with PHP info, save that, refresh this page, and I should get PHP info. There it is. Here is PHP info. And that line there, try and zoom in a little bit, confirms that the xdebug.ini file has gone in and it's been loaded into runtime. So if I go to search now and type in xdebug, I should get the, there we go, I should get the configuration settings. So here are all the config settings for Xdebug. And I can see if I scroll down, there we go. Xdebug remote host is host.docker.internal. So all of the Docker stuff is enabled and remote enable is on. Therefore, it just remains to see whether I can put a breakpoint into my code and actually stop runtime and have Xdebug running properly. And this is where I start sweating. So let's get rid of that DD. Save it. If I reload the page, I should get the page of my project. There we go. Zoom out a little bit. So are we going to run? If I go to merchant login, how about I do that? And I'm going to log in as this is a fixture in the project that we when we generate fixtures. And there we go. I'm logged in. So this is the dashboard for this project. Excuse all the lines and things. This is a development copy. If I open the Laravel bar here, which is the same as the Symfony profiler, I think it is, it gives me stuff like root and queries and views and things like that. If I go to roots, just make that bigger, we could see that if I just zoom in a bit, so you can see that the URI is admin/dashboard, and it says that it uses the dashboard controller, and we have as an invocable controller, and the root name is admin.dashboard. So if we want to stop runtime, then we need to hit that dashboard controller, and I'm going to tell it to stop. So if I zoom out a little bit and bring up my IDE, just close all this stuff. Go away, go away, go away, go away. Dashboard controller, please. Thank you. There we go. There's the invoke for the dashboard controller. So if I go to line 30, press that, and a red line goes across it, as you can see, and that is a breakpoint. Then just up here, we've got, you could probably, I don't know if you can see me actually toggling it. I don't think you can't see me toggling it because I think that StreamYard has very helpfully cut off the top of my screen. Oh no, you can see it. No, you can see it. There it is. So I've hit the little telephone to say, listen, I've set a breakpoint. If I reload this dashboard, and I'm not going to touch anything, I'm just going to hit reload. I didn't do that. The IDE did that. It brought it into the foreground. And then we have our Xdebug live coding window. Not live coding window, live debugging window. So success. And now I can sweat sort of slightly less. So just before I actually start talking about that, I'm just going to quickly go back to the slides. Just so you can take down a few notes for the Docker setup, because this is not exactly like amazingly straightforward, but once you've got the hang of it, you can roll it out. So important bits: Dockerfile, Pickle install Xdebug, custom PHP INI with an Xdebug environment variables injected in Docker Compose. You can use the Dockerfile itself if you want, which we have done on a couple of other projects. The PHP ID config, make sure that you set that to the server name. By the way, I'm motoring through these, so if anyone wants the slides, they can let me know. Remote port 9001, make sure that you do that so that PHP FPM doesn't conflict. Someone said before when watching someone like Matt Staffer, I think from Staffer from Titan, when he said you need to change it, otherwise it will conflict. And they said, no, it won't. And it did. So it probably will conflict. So just change it to 9001, makes things easy. And the remote IP for a Mac is docker.internal.nhost. One of the times I did this, it was the Windows. Now you could use WSL now, I think, really easily. Linux has something really, really simple that's quite simple. That's quite straightforward. It's not like the bad old days where you have to manually try and assign like custom IP addresses inside Docker containers. Thank God. So we've set it all up. Let's do some actual debugging. Because that's what we came here for. So, dashboard controller. I put a breakpoint and I stopped runtime. So I'm now going to show you. I'm now going to actually show you just a quick talk through about like all of the options and the panel the panels that are available to me, like all the things I can do. So, come on, pop out. There we go. On the left-hand side of this panel, you can see it's three parts of it, right? On the left-hand side is it's the stack trace. So whenever, like, if you use for many years I used Symfony and have that ghost, and that ghost would be like, oh no, an exception occurred, and then it would give you the stack trace. But Laravel does the same thing. It was mainly the bane of my life, but it gives you all the thing, and then when you've got a really bad error, you have to pour through the stack trace. Most of it doesn't make sense. Good news, this isn't just the stack trace, this is a completely dynamic stack trace. And you can navigate through all of your code by clicking on any of the bits. So if I scroll down, what I'm doing here is I'm scrolling back through the cool stack, and you can actually see Laravel as a framework doing all of its inversion of control and handing control and then bringing it back and things like that. So you can actually see the whole pipeline process. You can imagine why for debugging that is fairly priceless. So if I just move this down a little bit, it's quite difficult to sort of see all this because the thing is really sort of zoomed in. But like I'm at dashboard controller line 30, right? That's where I actually put the breakpoint. But if I go to the line before it, that's in the generic controller, and that's got cool user function array and it does stuff. If I keep on going, like the code, the actual editor window is navigating automatically to where we are in the stack, right? The next cool thing about that is the panel to the right is the variables panel, and that is the live variables that are happening at that moment in runtime. So as I navigate through the stack, the right-hand panel gives me every single variable, and which I can drill into. So for instance, if I go to the root, this part of the call stack here is router 685, and I have a request route and this object. This is the router because that's the bit of code that I'm in at the moment, but I have the request object and I can drill down into it. So at this particular time, here are all the proxies and things. Here is the request factory. Here is some Symfony components that have been injected in. I can do absolutely everything on here. It's fairly kind of amazing that you can do this. I say amazing. I think it's alien to a lot of PHP developers because stuff like this is available in Ruby and Python and is sort of second nature, but because Xdebug is not baked into the actual PHP runtime, you have to install it yourself. This sort of takes people by surprise. But honestly, when I saw this, I was like, this is amazing. Why isn't everyone doing this? So a couple of things to go through when it comes to navigation. You have these options here, which is starting with this tooltip here. So you've got, I'm just going to go back to where I was in the dashboard controller, actually. So I'm on line 30 at the moment. Step over executes the line of code and goes to the next line. And it actually you can actually just see that it just went through. The variables panel just updated, of course, because as you go through it, all of the dynamic panel just updates to whatever you're setting it. That's step over, and then step into. So you could see on line 30 that line 30 had a method called get time period for orders, but I told it to step over. I told it to execute that line and go to the next line. What happens if you want to drill into get time period for orders? That's when you choose step into. So that just steps into the next line of code, so you can keep on going layers and layers deep. You have force step into, which is if you want to, if anything has been called for the vendor directory or it's got anything third party that you've got, it forces it to go really, really deep down. And that's tends to be when you've got an application problem where usually an open source library or something like that has introduced a bug, and that's hopefully, fingers crossed, you should never get to that stage ever. But we all know that's not true. And step out enables you to finish. If you drill into this method, for instance, get time period for orders, you want to step out of it, you want to come out of it, right? So you could just, instead of just going step by step, once you're in there, you could step out, it'll just complete it and then take you back to where you came from. And run to cursor, my favorite line. So if I scroll down, I'm going to go to a line just before the response is returned in this controller, and I've just selected the caret there. Hit return, run to cursor, runs all the lines of code until I get to the cursor. Fantastic. So that's all of my control. Real debugging. I'm going to do some real debugging. Hooray! And I'm not going to do it via the web portion of it. I'm going to do it via unit tests, because I did say that we all did unit tests, because everyone does. So if I stop this, I'm going to run a unit test in the command line. So I'm in my container, vendor PHP units, no binary. Get it right. Come on, Jimbo. PHP unit, and I want to filter by a specific test, which is can add item to order. Run that test, please. Drum roll. Come on, PHP unit. You can do it. Failed. So this is where Xdebug and an IDE like PHP Storm are pretty vital, because when you're in unit tests, a lot of unit tests that we write are all usually emulating the front end, or doing things like using WebKit kind of stuff. In this example, the test wanted a 200, but it's got a 422. So it's just failed. And you can see the line of code, and it's on 114, and it says assert status is okay, but it's not. That doesn't really give me any more information. If we were going to do this the old school way, then that response object, we'd dump it out, and we probably wouldn't get that much. So we'd have to drill into it. So we'd have to do response get body, or response. It becomes sort of a tangled mess of spaghetti where you're trying to sort of work out what's going on. So we're going to debug it. If I get can add item to order, let's bring up that test. Can add item to order, and line, where is it? There it is. That is the line. Line 114 is failing, and it's failing because it wants an HTTP OK, but it's getting a 422, which is bad entity, I think, or unacceptable entity, or malformed entity, or something like that. So we need to look at the controller, and the controller is whatever is being hit by API /version 1 /order. So I happen to know that that controller is going to be add. Is it add item? Add order item. AP. There we go. API add item to order request this is the actual controller that's being hit. So, oh no, that's the request. Come on, let's hit the controller. Add controller. That's better. Add controller. There we go. So in this controller here, this is if I just hit a breakpoint. This is a good example of have I switched the debugger on yet? A good example here of debugging in action. This is a real world example that I encountered myself, and I was going, what's going on here? And it doesn't hit it, which means if you're going through the debugging stack and you're thinking logically, that breakpoint I've just set in that controller is not being hit, which means that something higher up is hitting it. So you can see the API add item to order request. I opened that up earlier, and the request has this is a Laravel thing, but you have something similar in Symfony. Has a set of rules, public function rules. It's a payload of configuration, right, of an array that configures things. So I'm going to put a breakpoint on here instead on the rules, and then try and run it. I really need a better internet speed. Okay, that has just hit that breakpoint. Fine. So if I'm going to now use the step over, and I'm going to start just executing code in the stack to see what's happening here. So this is a function called rules. So if I just step over, scroll down, messages, attributes, make right. On line 108, there is a variable called validator, and this is the validator that is validating the request, right? So it's doing some Laravel stuff at the moment. Validator set container. It's putting the validator into the service container. Add extensions. Method exists with validator. Then this with validator, and then set it. Cool. Okay. Okay. Here's the million-dollar question. We've got to this line, which is line 25. If instance fails, then do this, which is failed validation. If it doesn't, then it's okay. So if I run the next line, it hits it, which means that it's failed. So let's have a look at the variables window. And in the variables panel, I can see that I've got an instance of validator. So if I drill into that, in the validator, this is something that's sort of Laravel based, so I don't really know what I'm looking at. Oh, there's an array called rules there. Which is inventory ID, variant ID, merchant options. Okay, cool. And there is an array called failed rules. This is going to be what I'm looking at. So there's an array of 1, which is variant ID. It needs variant ID. It says required there. That says required. So no wonder it doesn't work. That means that's not there. So if I stop the debugger and go, close that, close all the stuff that I opened, and go back to the test. What is the test? Where is the payload for this test? There it is. Order item payload. Merchant, inventory ID, inventory options, but variant ID is not on there. So variant ID equals, presumably I have something like variant, inventory variant, ID. Okay, change the payload. Cool. I'm going to switch off the debugger as well because I don't want to hit it again. I want to see what happens on the test. Passed. Bingo. That was live debugging in action. Watchers. let's get on to watches. I love watches. Let's go back to the dashboard controller. And a watcher, you can see this if you open up your DevTools in any browser worth its salt. You can just, it does exactly what it says on the tin. It's a watcher, so it watches for a variable and keep you updated. So an example of this in action is you can see on line 40 we have an array. It's a what's the word I'm looking for? It's a my brain has gone to mush. I've got a variable called dashboard metrics. So I'm going to do some stuff to it. So dashboard metrics. So that equals get front end statistics for merchant with date range, and it brings back something. But then I'm going to say dashboard metrics equals this my mystery method. This is emulating some lines of code that you've been asked to debug. You've picked up something and it's broken, and it's my mystery method because you don't know what it is. It could be absolutely anything. It could be further up the stack. It could be not inherited. It could be some sort of decorated pattern anywhere. Who knows what it is? Dashboard metrics equals this my other mystery method, which also takes dashboard metrics. So I'm doing a bit of mutation on that, and so I can show you exactly what a watcher does in action. So I'm going to put a breakpoint in there just before it hits. Switch on the debugger, go to my application, which previously timed out, not surprisingly. Merchant login should take me to the dashboard. Cool, and it does. So I want to watch dashboard metrics. So if I bring up this, you've got the call stack on the left, you've got the variables panel, and the one that's missing is watches. So if I go here and type in dashboard metrics, press return. At the moment, it says cannot evaluate expression because it's not been set. So if I run the code until I set it, so which is now, so line 40, run that. Dashboard metrics is now an array of 4. Cool, there it is. Looks like that. New order, processing completed, rejected. But if I run the next line where it uses my mystery method, you can see that it looks exactly the same. New order, processing completed, rejected, 8333. So my mystery method doesn't do anything. But if I run the next line, it now looks like that, which is dashboard metrics is 74, 34, 28, 30. It's changed everything completely drastically. So if I use the IDE to drill into my other mystery method like this, I can see that this method goes through everything in the array that's given to it and does a for each on it and adds a random integer of 1 to 150. That's basically live coding in action, a live demo of debugging in action. So you can identify the offending method. Runtime modification. This is probably my favorite feature of PHP Storm. And it goes a little something like this. I'm going to take out those methods, right? When Xdebug hits a breakpoint, it will complete, if you want it to. It'll complete runtime. It stops runtime, but whatever you do to it will modify the runtime and then put the output on the other end. So we went through that my mystery method thing, which changed the output. So I'm going to switch off the debugger, go to this dashboard here. And this dashboard here, you can see that in this panel here, you've got new orders 8333. So I'll let you in a little secret for the, even though it's open source, so it's not really, there's no secret source to it. But that payload of those dashboard metrics is output, and then this blade template reads it out. So there's nothing stopping us from modifying runtime if you want to. You can do it with anything as well. It doesn't have to be a runtime with blade templates. It could be an API call that Vue makes or React makes. It doesn't matter. So if I put my breakpoint back on, I'm going to put it on dashboard metrics. There we go, like that. And reload the page. And now I know that I have to do this really, really quickly because I haven't set my timeout on Xdebug to be very long. So if I reload the page, The page looks like it's loaded, probably because I haven't switched on the debugger. Yeah, I should probably switch on the debugger. Come on, Jim. What are you doing? Oh, it's late on a Wednesday. There we go. So I'm going to run that line where dashboard metrics is set. We know from our watcher, and our watcher's updated there. But I have a live console, which is like console.log on a JavaScript window. And I'm going to say dashboard metrics now equals this, my other mystery method, and plug in dashboard metrics like so. Press return. It's changed it to 106.5.18.13. Okay, cool. If I close that and then I press this button on the left-hand side, it resumes the program execution and lets the whole PHP thread complete. So if I go back to the dashboard, it is loaded. And now my dashboard says 106.5.18.13. If you think of the power of modifying runtime, you could do that with anything. If you have Symfony or you have Laravel, you can completely change the whole of the service container if you want to swap out a service. You could just do anything. And that is pretty amazing. The last bit of this is conditional breakpoints, which is quite funky as well. So I'm going to give you another hypothetical example, which has actually been used in practice. So if I go back to this dashboard controller here, and let's say you've got a hypothetical situation where certain users are complaining of a bug where something doesn't load. So you need to cycle through what the potential problems might be that are causing those. So I'm going to put a breakpoint on this line on line 32 near where the controller is invoked. And if you right click on it in PHP Storm, you get the conditional window. So the conditional window I'm going to put a condition, which is the merchant that's fetched back, who is logging in. We have a piece of domain logic on this, business logic called allow table service. That's what it says on the tin. And I'm going to say equals to 1. I only want you to hit this breakpoint if allow table service on that entity is 1. That will allow me to debug better. You can see very, very slightly that that there's a little question mark in a speech bubble on in the next to the breakpoint, which tells you that there's a condition set. So if I go back to the code, I now go to log in as the merchant. Nothing happens. Good. This merchant is okay. So I'm going to log out. And I'm going to log in as merchant number 2, which is test2 at test.com. I'm very imaginative with my naming. Didn't touch anything. Now your debugging is open for, and you already know why it's triggered. So enables you to continue drilling in more into your code to find out what's wrong with it. How lovely. Right. Let's go back to the slides and just do a bit of sports casualness. So, things that we saw in the demo: breakpoints, console, and steps, watches, dynamic stack trace navigation, conditional breakpoints, runtime modification, and profiling. And I'm only going to show you very, very briefly what profiling does because I don't want to run out of time. So in our sports casual way, I'm going to compare it to cars because I am a man that has very small hands. So for Mondeo and is going to apply to the breakpoints, console, and steps and watches. And the reason why is because, like I said, if you want to bring up JavaScript runtime in your browser or you want to do it on Node, you have all these things, right? These are just native to most programming languages, right? C++ has one, and you've got .NET Core's got one, right? But dynamic stack navigation, the way you can do it in PHP Storm, and conditional breakpoints for when you need more in-depth logic for debugging, they go down as our BMW Minis because slightly enhanced, and that's quite cool. Runtime modification and profiling is the real gold dust here. That's some of the best featuring, especially with profiling. And I'm only going to show you a very, very brief demo of profiling. So profiling by profiling, we mean that it's going to, you can enable Xdebug's profiler to log absolutely everything and then create more than just a call stack. It will create the entire call stack, right? So you do it with, the example I've got is using a container called WebGrind. I'm not going to install it properly. It's already installed just to save a bit of time. So if I stop this, I can compose, and I have a container in here called WebGrind. There it is. The way that you set it up is it has a temp folder on the right-hand side, and I'm going to take my /storage/Xdebug folder locally and mount that into the temporary directory. You then, in the PHP INI, I might as well do this bit to show you because otherwise you won't know. So you've got, these are the INI settings that we set before. So if you add these 2 lines, you've got profiler enable 1, and you've got profiler output directory that tells it where to output it, right? So once you're running it, and I'm going to show you WebGrind from a live example of loading that dashboard that I showed you before. So it is localhost 8081. There we go, 8081. There's WebGrind, and I'm going to. I need to zoom in a bit because you presume, yeah, that's not very visible. And I'm going to say what folder, what files are in there. Here is one that I prepared earlier, and this is the entire call stack for that login to that dashboard. And you could do some fancy stuff. So there's an invocation count on here. So if I click on that, that is going to order all of the function calls and the whole stack to tell me what's being called the most. So if you want to make if you've got a bottleneck in your application, then you can start to see where the most cost time in terms of milliseconds is being executed. So we can see that PHP is null and PHP is array, for instance, is the highest of 3,168 and 2,100, and that costs like 0.7 milliseconds on everything each time it's called. But then there's some other stuff like you can see here the Illumination found it, which is the namespace for Laravel. The application and the closure of the application, that's the whole of the Laravel application itself, is not surprisingly quite high up. So you can see how much that's spent. And you can, with WebGrind, you can show a call graph, which then turns it into an SVG for that call. Here it is. Just going to zoom out. There is an entire one PHP thread call. And if you zoom in, it will give all of the percentage of CPU that it takes and the amount of time it takes spent. So you can imagine how powerful that is once you learn how to read that kind of stuff. And I'll cover that on my final slide with the conclusion now, on why that's important and why it's got us as a kind of, why it became a sort of talking point. So what we found from rolling out Xdebug across our projects, which we have chosen to do that as part of Jump 24's technology stack. Now, Xdebug is included as part of it, and as a developer, you're expected to know how to use it. If you don't, then we teach it. We sort of teach each other internally how to do it, right? So things that are important about this: time is money, but it's also an investment. So when I say time is money, people aren't rolling out things like Xdebug or features or Grum PHP, as mentioned before, because it takes too much time to set up. But it is an investment. If you have a legacy code that a legacy project that your company has taken on, you will probably shave off massive amounts of developer time with putting Xdebug and enabling that developer to actually go through in more finer detail without having to kill the PHP runtime every single time by dumping out the session. So, that's an investment, and it's saved me on some of the projects I'm working on vast amounts of time, and time is money. And also the ability to look into this level of fine detail with Xdebug means you start understanding what is happening in the call stack of, in our case, Laravel. If you want to use Cake PHP, or you use Slim, or you use Symfony, or it'll enable you to drill into that. It levels up your team. It gives you more understanding of the PHP runtime, and that is something that we are all about at Jump 24. We are very big into leveling up our developers. On a personal level, big warnings: don't switch it on with everything, and don't put it anywhere near production because it will murder everything. Make sure that you have contained your development environment so that nothing else is reliant on it. Like if you wanted to debug something and you had a UAT server, it's a database server that that people's local environments connect into, and that's happened on 2 different projects on old companies that I worked on. Then if you go like, oh, let's turn on Xdebug, it will kill everyone's session, right? So make sure you have ring-fenced that environment. And the profiling, we've kind of discussed this, that it gives, we do TDD, so why can't you do performance-driven development, or PDD? So if you ship a feature, why not? Because we have the ability to run Xdebug locally now, why not test that new feature to see if there's N+1 issues or the call stack is too big? That's what it's enabled us to do. And coming in at only a couple of minutes overtime, somehow, that was me. That is how we turbocharged our development with Docker, PHP Storm, and Xdebug. Thank you very much for listening, everyone. Whew.
Wow, that was quite a lot of information. That was really interesting. Thanks for that.
Sorry, it was a bit of a whistle-stop tour there, but I found that if you try to go into more detail with it, it's it can go on for like an hour and a half.
Yeah. I've used Xdebug in the past with Docker and PHP Storm, and it was quite a fun experience to set it up properly and get it working. So good tips.
I think now it's kind of easier than it was before, because I did it back with old school lamp stacks in like 2014, and I was like, "What is this? I hate it."
Yeah, I didn't know about the Docker .host.internal thing, so that's a good tip. I did it the old school way where you work it out in Bash, and
yeah, so that's a couple of jobs ago that someone did that, and it looked so fiddly. I thought I'm never going to remember how to do all this.
Cool. Well, apparently there's no questions from people.
I've just bamboozled everyone, or everyone's fallen asleep.
Hopefully you can tweet about your slides and people can dive in and have a go themselves.
Yes, I've not actually shared my slide. Oh, it's worth noting for everyone that that you can see, if you go onto Jump24's website, you can see the or you can go onto dev.to, you can see the accompanying article which does talk through this. The accompanying article and everything that we've done and that you've seen tonight has come through because of that tweet, but also mainly through Matt Stuffers, who runs a agency called Titan, and Gary Hokin from Twilio basically took on with Derek, basically created a load of content from it. So it's on a website called learnxdebug.com, I think, and you can find loads and loads of resources. So if you like what you see but you use VS Code, there's a whole tutorial on how to do all of that in VS Code. So it's pretty cool. This article is on there as well, of course, but it's been the work that they put in to start with that got everyone talking about Xdebug again has been pretty vital.
That's great. I particularly liked the bit about test-driven development, which is something my team does, and how we can link that into Xdebug, as it's not initially kind of obvious that you would do that, as theoretically you're writing the tests which prove the code works, and therefore why would you debug it? But as you say, diving into it that way is quite useful.
All you get is Circle CI just going, nope. And you're like,
yeah,
but what? So for almost every, we have we do a sort of Laravelli kind of way rather than I used to do a lot of work in Symfony, which was a bit more. I mean, I preferred the way the controllers were to the best practices, but in Laravel, like everything is a controller, like every single action. But that is kind of the best practice way of doing it. But with every single invocable controller we create its accompanying test. So you can imagine what if you look on order, if you look on GitHub repo for it, you'll see that the test suite is absolutely massive. But because we've got one test for every controller, when they fall over, we've generally found that that the ability to debug that with Xdebug, whilst it's mimicking a web controller, is pretty vital.
Regarding the performance, I've even found that leaving the Xdebugging extension installed but not enabled still has a performance drain.
Yeah.
It's quite
Yeah.
unexpected, but yeah, just remove that completely from your production image.
The way we've done it is we've got sort of the a sort of DevOpsy pipeline for the way that we're deploying stuff, and you have some environment variables sort of set for higher up, and it will just not touch Xdebug unless you set those environment variables, so that whatever's deployed doesn't have the extension. It doesn't try and set any INI stuff. Just doesn't do anything. You just leave it well alone. If you accidentally leave the profiler on, your application will stop working.
Yeah, we use different variants of the production Docker image. Basically, one has Xdebug, one doesn't. So in dev, you'd use the more debuggy version, and in production, it'd use a clean version without Xdebug installed at all. Cool. So basically, we've run out of time now for the talks, I think. But if you'd like to move over to the social section of the big orange hat platform, then feel free to join a table and talk to us more about this.
I will sadly be heading off because I need to find out if my son has gone to sleep or has screamed his head off for the last hour. But as mentioned in the talk, if anyone's got any questions, then you can reach me on Twitter or LinkedIn at SirConJ, and I'll be happy to tackle stuff. I think the next thing I'm going to tackle now that I have a new member on my team at Jump24 is probably going to be sort of half microserviced environments that have multiple domains in PHP Storm. So there's multiple workspaces. So that's going to be kind of an interesting challenge.
Cool. Thanks a lot for your time.
Cool. And, thanks for hosting me. Both.
Have a good evening.